reaction. Okay, all right. So catalyst is added because it helps to increase the rate of reaction. Okay, it affects the rate of reaction without being used up. So it may help bring a system to achieve equilibrium faster. It helps to achieve equilibrium faster by increasing the rate of both forward and reverse reaction to the same extent. Okay, as you know, reaction involving equilibrium is a reversible reaction. Reversible means we have rate forward and also rate reverse. So how does catalyst act? Okay, how does catalyst behave in this type of reaction? Because we have rate forward and rate reverse, not only rate forward. Okay, so basically it helps to increase the rate of forward and also the rate of reverse reaction, okay, to the same extent. So addition of a catalyst does not affect the position of equilibrium, and therefore it will not affect the value of K. It will not affect the K. Okay, all right, so this is already this profile energy diagram is I believe this is you are already familiar with this energy profile diagram. Okay, it shows the characteristic of catalyst. Okay, so this is how later on, in case you are asked to draw the energy profile diagram for a catalyzed and uncatalyzed reaction, this is how you should be drawing it. Okay, all right, so the starting point should be the same. The reactant, the energy of the reactant should be the same, and then you have the uncatalyzed, which is higher than the one that is catalyzed. Catalyzed means with catalyst. This one is without catalyst. So this is the EA of if catalyst is added, and this, okay, the red one from the top here, until the reactant, this is the EA without catalyst. Okay, you can see how different it is. Okay, so the ending, okay, the end point should be the same. The end point means the energy of the product lah. The difference is in terms of the EA sahaja. Okay, kalau you buat dia punya starting point berbeza dengan ending point dia berbeza, that is wrong. Okay, itu salah. Alright, okay. Okay, so that is all for factors affecting chemical equilibrium. Okay, alright. Maybe you can try out this checkpoint 21. Okay, very quickly. Okay, based on what we have learned so far. Okay, in which direction will the equilibrium shift when? Okay, let's try out this question, guys. Okay, focus on this question. Checkpoint 21. Okay, this is like combination of all the factors. Okay, combination of all the factors. Okay, so this is the question. This is the reaction, and this is the delta H. From the delta H given, we know that this reaction is an endothermic reaction because the value is positive value. The value of delta H is positive. Okay, right, identify the reaction first. This is forward, this is reverse, and then question, in which direction will the equilibrium shift when? Okay, N2O4 is added. So this is N2O4. So when N2O4, that means when reactant is added. Okay, added as in, added can be in terms of concentration, mole kan. So let's just assume the added N2O4 is in terms of concentration. Okay, all right, when the concentration of N2O4 is increased. Another word that we could use for A is concentration of N2O4 is increased, sorry. Okay, all right, so when this one, dia tanya direction saja. The question is only asking for direction. Dia tak tanya what will happen to the product, okay? And you don't have to elaborate further because dia tanya which direction sahaja. It's either to the left or either to the right or to the right ataupun to the left ataupun forward or reverse reaction. Okay, all right. Kalau nak extra saja, nak practice, okay, maybe you can if moving to the right, and then the concentration of NO2 will increase and so on. Okay, all right. Come back to A, N2O4 is added, guys. In which direction will it proceed to reduce this stress? Kemana? Kanan ke kiri?
Kanan.
Okay. Alright, ke kanan ataupun it will proceed to the forward reaction. Okay, kenapa? Because this is increased now. The reaction is now no longer at equilibrium, so the reaction is stressed. So how the reaction to behave ataupun counteract the stress added to the system? By shifting to the right. Kenapa nak shift to the right? Because when it shift to the right, it will consume the extra N2O4 added just now. Okay, it will consume, dia akan menggunakan the extra N2O4 just now and to produce product. Okay, so at the same time, the concentration of NO2 will also increase because dia gunakan ini untuk produce product. So product will increase and eventually the new equilibrium will be established. Okay, alright, so how about if NO2 is removed? In which direction will it proceed, guys?
Right.
Okay. NO2 is removed, okay, to the right. And then how about the rest?
To the right.
To the right lagi?
Right.
To the right.
Tiga. Okay, alright, good. Okay, to the right because this one is removed. That means in the way dia nak cakap the concentration of NO2 is decreased. So now they stress because they decrease sekarang. Okay, so to reduce the stress, the reaction need to proceed to the right. Why? Because to increase up this concentration of the product. Okay, alright, okay, C. The total pressure, okay, so now we are talking about pressure, guys, okay? Be careful, pressure dengan volume. Okay, pressure and volume. If you are given pressure, dia senang sikit, dia direct. If you are given volume, you have to relate with pressure. Okay, at any time you have to relate volume with pressure. Tapi kalau dia bagi pressure directly, senang. Sebab kita memang nak pressure. Tapi sometimes soalan can be tricky. Not lah tricky enough kan. Tapi instead of giving you directly in terms of pressure, the question give you in terms of volume. So what you need to do is to relate with pressure. Okay, then only you can predict, oh, pressure is lower. How can we increase the pressure? We can increase the pressure by moving to the side that have more molecule. Because more molecule, we produce more pressure. Okay. Okay, alright. The total pressure is increased by addition of helium at constant volume. Salam. Itulah nanti saya nak cakap tak settle lagi benda. Siap lupa. Nanti kita cerita Okey tak. Sorry for the interruption. Okay, the total pressure is increased by addition of helium at constant volume. Okay, alright. Remember last time we have two conditions kan? It's either constant volume dengan constant pressure. Okay, so ada one of that condition tu it produce no effect. There will be no effect if helium is added ataupun if inert gas is added. Okay, alright. So C ni is when inert gas is added into the system. So we know that when inert gas ataupun gas is added into the system, when gas is added into the system, what happen is that we will increase, the total pressure of the system will increase. The total pressure of the system will increase because why? Because we add more particles in the container. So the more particle we have in a container, in a reaction mixture, by right, more pressure is produced. Okay. However, you have to consider the condition. The helium ataupun the inert gas is added in, okay, ataupun at constant volume. That means the volume will not change. Okay, whatever happen inside there, the volume will not change. The volume will not expand. Okay, all right. So what will be the answer for C, guys? In which direction will the equilibrium shift?
No change.
No change.
Okay, alright, so we have no change. Any other answer than no change? Ada yang would like to try to the left ke, to the right ke? Okay, alright, so the answer is no change. You kena consider this one, please be careful. Kalau normally it will be constant pressure lah, but unless it is specified constant volume, so you be careful. Tapi after all no change kan, kalau constant volume kan. Tapi selalunya dia constant pressure. Okay, that means the volume can be varies kat situ unless it is mentioned. Sebab kalau dia cakap constant volume, no change lah. Okay, tapi students sometimes they tend to, take for granted lah. Dia nampak pressure dia tak sabar-sabar. Okay, pressure, increase pressure nak lowerkan pressure. Tak sabar-sabar. You have to read the question till the end. Okay, sebab dekat yang ending tu yang selalunya yang student miss out. Dia excited, dia is increase, increase. So nak decrease kan, how pergi ke side yang left, ke side yang less molecule. Okay, alright. Read the question till the end. Okay, D, the volume is increased. Okay, like I said just now, you have to relate volume and pressure. Okay, volume increase, that means the pressure will decrease. Okay, alright. So this is the relationship that we have so far. P is inversely proportional to V. Okay, so when volume is increased, that means P is decreased. The pressure is decreased now. So the system is at stress. Alright, okay, so the system need to overcome this stress by, okay, increasing the temperature, the pressure, increasing the pressure. So how can the system act in such a way that the pressure will be increased? Okay, so it need to shift to the side that tadi pressure rendah kan, it need to shift to the side that has more molecule. In this case, which sides, guys?
Right.
Right, okay. Some more?
Right.
Right.
Right, right,
Right.
right, right,
Right.
right, right. Okay, anyone answered to the left? Okay, alright, so the answer is to the right. Kenapa pergi right? Because right on right. Okay, make sure untuk you main dengan pressure, dengan volume ni, you only consider the gases phase sahaja. Okay, not other liquid, aqueous ataupun solid. Jangan kira dia punya ni. Kira consider only the gas phase sahaja. So this is 2, this is 1. Okay, alright, because on the right we have more molecules than on the left. Okay, the temperature is decreased, guys. Okay, when the temperature is decreased, the system is at stress. Okay, alright, so when we solve for temperature, the tips is, the tip to solve for temperature, you have to consider the heat. Okay, there's always heat. Okay, when the reaction occur, there's always heat involved. It's just that kita punya focus is not on the heat lah. Unless we study thermochemistry last time, kita punya thermochemistry, right? We want to study the heat transfer, the energy transfer. Okay, then we focus on the heat. But normally macam topic 1, apa nama tu? Topic 1, semester 1 last time kan? Okay, we study the temperature but we are not concerned on the energy transfer. Tapi ada sebenarnya energy tu, cuma kita tak nak fokus on the energy. Okay, but we have energy involved in each reaction, every reaction. That's why every reaction has its own energy profile diagram. Walaupun reaction dia kecil, every reaction has its own profile energy diagram. Okay. Alright, so for this one, you have to consider, okay, you have to know the type of reaction first. So this is an endothermic reaction. Okay, since it is an endothermic reaction, maksudnya the reaction absorb the heat in order to produce product ataupun in order for the reaction to take place. Okay, alright, so you will need to place the energy. So this is endothermic, right? So you need to place the energy ataupun the heat ataupun delta H ke whatsoever, okay, to represent the energy on the reactant side, because this is endothermic. Endothermic means the energy will be absorbed. Okay, the energy will be absorbed. Okay, so this is the reaction. Okay, so bila you deal with temperature, the temperature will attack the heat. I mean, macam concentration dia akan attack either reactant ataupun product kan. Tapi kalau temperature, okay, it will attack the heat. But you have to identify the location of the heat first, the position of the heat, whether it is on the reactant side or is it on the product side. Okay, once you have placed the heat on the reactant side, senang lah. Okay, alright. So you treat dia macam you buat concentration. Okay, when temperature is decreased, that means when heat is decreased lah. When less heat, okay, is provided into the system. So what will happen? Okay, maksudnya sistem disejukkan sebab less heat kan. So assume that temperature will decrease lah. The temperature will go down. Okay, so the system is at stress. So bila system stress, how can the system react so that the stress will be reduced? So dia kena increasekan balik the temperature. Okay, so in order to do that, the reaction need to shift to the side that produce more heat lah. Takkanlah absorb lagi heat. So dia kena produce heat sebab temperature kan dah rendah sekarang ni. So how can the system react so that the temperature will be increased? It's either to the right ataupun to the left kan. Okay, cuba you try. Okay, you dah tahu you nak produce more heat. So kalau you pergi ke kanan, it will reduce, it will absorb the heat. Okay, so kita nak dia panas, kita nak dia produce more heat. So it will need to shift to the left. Bila dia shift to the left, it will produce more heat and the temperature will increase back up. Okay, dia akan increase back. The temperature will increase lah. Okay, so the answer will be to the left. Okay. Yeah. Okay, let's just check. Okay, roughly. Okay, just now kita kata dia to the right, betul. This one no shift in the position of the equilibrium just now. Okay. The system will shift to in direction occupy larger volume. Okay, this is shifting to the right. Okay, endothermic also shift to the left. Okay, as you can see, dia being extra kat sini, even though dia tanya the shifting. Okay, but for your practice, in case exam dia tanya explain ke apa kan, you know how to explain it. Okay, so give extra lah, give extra for your tutorial. In exam, kalau dia tanya shifting kan, and then only 1 mark is provided unless the question specify shift and then mention in terms of shift and also what happened to the product. That means you have to specify lah, even though the mark is only 1. If the question only asks for the shifting and the mark is only 1, that means you bagi shift je. You tak payah buang masa bagi yang lain. Okay, so we subject to the question asked. Tapi dalam tutorial, this is for your practice, bagi extra. Practice bagi extra. Saya pun boleh check kan, and I can also comment on that. Kalau you tak nak bagi extra, saya mark based on apa yang you bagilah. Okay, so I really advise you in your tutorial, you being extra lah, explain further. Okay, in case dalam exam tanya, you dah ada, you dah ada that I mean idea tau. And then dia punya word, dia punya statement tu dia flow, so dia cantik je keluar sebab you dah pernah gunakan that information before in your tutorial. Okay, alright. Any question related to the factors affecting chemical equilibrium, guys, before we proceed to application of the principle? Anyone?
No, madam. Okay.
Yeah, all right. Okay, all right. So if there is no question, let's proceed to the last part of topic 2. Okay, application of Le Chatelier's principle. Okay, so we have 2 application that is very famous. Okay, that has been using this principle for the longest time. Okay, we have Haber process and the other one we have contact process. So ni proses yang sangat famous lah. Okay, to produce, one is to, Haber is to produce ammonia. Okay, the production of ammonia is the process is known after its scientists. Okay, so scientists ni discover process to produce ammonia atau reaction to produce ammonia by using this principle, the Chatelier's principle. And then the other one we have contact process. Contact process is a process to produce the reaction and process involved in producing sulfuric acid. Okay, so sulfuric acid. So these two are produced industrially tau. Secara industri, secara besar-besaran. Since long time ago, till now, they're still using the same process. And let's start with Haber. Haber, kenapa di Haber? Because of the scientists last time. Okay, so it was 1868 until 1934. Okay, so this process is was invented by Fritz Haber, that is essential in synthesizing ammonia in large scale production. We are talking about large scale, that industrial punya scale. Okay, ammonia is very important. Okay, it has so many application. Awak tahu dalam reaction je kan, tapi ammonia in our real life has a lot of application. For example, okay, it can be used as fertilizers. Dia digunakan sebagai fertilizers, sebagai dyes, okay, in textile industry, in chemical industries. So it has so many applications. So ammonia is very important. Okay, alright. So last time, if you want to read further related to how the process came about last time, okay, macam mana, what's the issue sebenarnya? Setiap proses sebelum kita come out dengan big process tu, mesti ada issue behind it. Okay, so last time, yalah zaman tak ada apa nama tu modern punya teknologi kan. So especially in the farming industry, okay, dulu zaman tok nenek dulu kan, kita mana ada mechanical punya ataupun teknologi yang advance. At least you need fertilizers to grow your plant. Nak buat apa? Nak makan. Okay, so at one point bila you keep using the tanah, okay, you keep using the soil tu, tanah tu akan deplete dia punya nutrients. Okay, and then how would you grow your plant kalau tanah tu dah tak subur? Okay, dia dah tak subur. So how you grow your plant? Macam tu matilah, and then kita akan ada kebuluran and whatnot. So how do you solve this problem? Okay, so you need to produce, you need to produce fertilizers lah dekat sini. Okay, you need to produce fertilizer synthetically. Okay, so one of the process is known as Haber ni lah. Haber allow us to produce, this process allow us to produce ammonia in large scale. Okay, so kita able to fertilize the soil so that farming can be done efficiently. Pokok pun tumbuh ataupun makanan yang kita tanam daripada pokok akan tumbuh dengan lebih sihat, and then kebuluran pun berkurang. Okay, alright. So that is one of the application lah, very important application in fertilizers punya industry. Okay, so ammonia can be produced via the following reversible reaction. Dia reversible sebenarnya. So we need nitrogen, we need hydrogen. Okay, when these two react, it will produce an ammonia. They produce ammonia, but this is reversible. After a while, ammonia tu dah cukup. Okay, it will, initiate the reverse reaction. Okay, forward, reverse. Okay, and this, of course, will have an equilibrium. Dia ada equilibrium state, and this reaction is an exothermic reaction because it is less than zero. The reaction is exothermic. It release heat. Okay. Okay, since this is produced in large scale, industrially. Okay, imagine macam mana industri. Okay, so macam mana industri nak increase the production of ammonia. So this is our target product, guys. This is our target product. We want more ammonia. We want more ammonia. Okay, so how can industry produce more ammonia? Okay, because this is our target. This is our interest product. So macam mana nak produce more ammonia? So kita kena play around with the principle because we know that this is reversible reaction and it has an equilibrium state. Okay, how can we manipulate? How can we manipulate this reaction? How can we manipulate the factors ataupun this reaction in order to produce more ammonia? Okay, alright. So ada 3 ways we can increase the yield of ammonia. Satu, by adding the reactant. Bila kita increasekan any of this reactant, it will cause the reaction to shift to the right. Betul tak? Remember, kita nak produce ammonia. It will cause the reaction to shift to the right, which produce our interest product. And alternatively, we can also remove the product. Okay, when we remove the product, imagine bila buat reaction tu, you keep removing the product. You say remove the product tu. Okay, so the reaction will shift to the right. Dia akan tetap produce to the right sebab the product keep decreasing. Remember kenapa dia nak ke kanan? Because bukan saja nak produce product, dia nak achieve equilibrium. The reaction itself want to achieve equilibrium. Okay, tapi kita ni manipulate by removing the ammonia because what we want is not for the reaction to achieve equilibrium. What we want is for the reaction to produce more product. Okay, kita nak ammonia tu. Reaction nak equilibrium. Ya, tu yang kita manipulate dia tu. So that kita dapat apa yang kita nak. Okay, alright. This would be the easiest one. And then we can also manipulate in terms of pressure. Okay, we can manipulate in terms of pressure. So we can increase the pressure. Okay, we disturb the system by increasing the pressure of the system. So what will happen is that bila kita increase the pressure, when we increase the pressure, the system is at stress lah system kan sebab pressure tinggi. So the system need to lower down the pressure. So how can a system lower the pressure? See, ini 1 tambah 3. 4 dia punya. On the left hand side kita ada 4 molecules. 4 mole of molecule. On the right hand side we have 2 mole of molecule. Okay, so when pressure increase, system stress, system kena reduce back the pressure, so system needs to shift to the left, which is producing less molecule. Less molecule means less pressure lah, which is again to the right, producing ammonia, producing our target product. Okay, nampak? Kita boleh main dengan reaction tu, dengan by applying the concept of Le Chatelier's principle. Okay, alright. However, you have to bear in mind that cakap tu senang. Increase pressure, decrease pressure, increase pressure, increase volume. Cakap je senang kan? Increase pressure. You boleh imagine tak increase pressure? Maksudnya pressure sangat tinggi. Okay, the higher the pressure, the better lah. Sebab dia akan shift to the right. Okay, but the problem is that like I say, high pressure shift the equilibrium to produce more ammonia, but this is not economical. Okay, this is very expensive. When you are talking about pressure, you are talking about very expensive condition, very extreme conditions. Sebab pressure sangat tinggi. Kita bukan main sikit-sikit punya pressure. You imagine our normal pressure is 1 atm. Tapi kalau industri dalam kilang, the pressure can achieve 100 atm. Boleh imagine tak 1 atm dengan 100 atm? Berapa bezanya tu? Okay, even kita dekat dalam laut tu 3 atm pun is dah can cause danger to us. Ini imagine dia main puluh-puluh ratus-ratus atm. Okay, that means you imagine you have to prepare dia punya condition tu, okay, dia punya materials yang untuk buat reaction tu must be very, very strong because the material need to withstand, kena bertahan dengan high pressure that high pressure. So that material tu yang boleh bertahan tu is very, very expensive. Dia bukan boleh pakai aluminium biasa, dia bukan boleh pakai iron. The material to be very, very, I mean the tensile strength and whatsoever, so that it can withstand, okay, it can withstand the high pressure. So this is very expensive. So very expensive pun, industri pun, it's not as easy as that lah. Memang kita nak the product to be high, but at the same time we do not want to spend more. Okay, we do not want to spend more, and it is also dangerous juga when we are dealing with high pressure. Okay, so this is something that kita kena consider. Bukannya kita nak nak produk je banyak, tapi kita kena compensate. Maksudnya kita kena spend, not necessarily. Bila you are talking, when you are dealing with industry, money and time is very important. We do not want to spend more, tapi produk yang kita untung tak banyak sangat. Okay, so you kena be balanced. Okay, alternatively, we can also play around with the temperature. We can reduce the temperature because since we know that the reaction is exothermic, guys. Exo, that means kita ada delta H ataupun the reaction produce heat lah dekat situ. Okay, when we reduce the temperature, imagine kita rendahkan the temperature, the system is at stress, so the system need to produce more heat sebab nak panaskan balik kan. So in order to produce more heat, the system will shift to the right, again producing more ammonia. Okay, producing more ammonia and also heat. Okay, alright, but you kena consider juga, bukan main simply turunkan temperature. Okay, sejukkan dia. Not as easy as that. You have to consider a lot of things when you are talking about industry. Okay, industry. So we know that low temperature shift the equilibrium into producing more heat and ammonia. We know that. Okay, but the reaction rate is slower. So satu lagi issue dia. Okay, temperature affects the rate. The higher the temperature, the higher the rate. Betul tak? But now we are talking about decreasing the temperature. Memanglah dia increase the amount of product produced. Tapi since the rate is very slow, you imagine rate tu sangat slow, it will take forever. Dia akan lama. Okay, memang it has the possibility to produce more product, but it will take longer time. Again, industry is very concerned on money and time. Okay, so tak semudah macam tu lah kita kata, okay, lowerkan the temperature lah. Yes, the lower the temperature is good in terms of producing product, but in terms of rate, it will be very, very slow. Okay, it will be very, very slow. That means kalau katakanlah contoh, kalau normal temperature, it will be rate dia laju, tapi bila you can produce the product in terms of one day punya time. Tapi kalau you reduce the temperature further, okay, you akan dapat banyak produk, but you have to wait for like 1 week. Okay, kena tunggu 1 minggu untuk dapat that product. Okay, baik buat normal temperature je macam tu. And because we can get the product in 1 day kan. So banyak benda you have to consider. So at the end of the day, they came up with the compromise reaction condition. Okay, we can call it as optimum condition lah. Compromise ni maksudnya taking into consideration the pressure. The pressure is still increased but to a certain point. Same goes to temperature. The temperature is still decreased but to a certain point, not to be very low. Okay, tapi ada point lah yang dia okay, cukup sampai situ saja. Don't go beyond that, because if not, it will take longer time. Okay, so these are the temperature. As if macam cakap reduce temperature tu macam Rendah sangat kan, tapi nampak tak 450 degrees Celsius is considered lower lah. Okay, is considered lower. Pressure is 200 atm, so do not exceed this 200 atm because it will be it's not economical lah. The pressure will be very high and it's also dangerous. And of course, industries relies very heavily on the catalyst. We need catalyst. Okay, so the catalyst used for Haber process. This one you have to memorize. Okay, is iron, and this iron is efficient at 400 degrees Celsius. This is what we call compromise. Okay, we need catalyst to increase the rate of reaction, and this catalyst is very efficient at 400 degrees Celsius. But at the same time, kita conflict, kita kena reducekan the temperature. Okay, that's why kita panggil the compromise. Kita kena consider both condition. Okay, we don't want it to be that low, and at the same time we don't want it to be jeopardizing the rate of reaction. Okay, so bila jeopardize the rate of reaction, it will jeopardize the catalyst punya efficiency. Okay, alright. That is banyak kan. Saya kalau cerita pasal industri ni seronok sikit kan. Rasa macam kita apply kan. Gitu kan. Sedangkan satu slide je. Nampak tak betapa lama ni bercakap pasal tu. Next we have contact process. Okay. It is the current method. In fact, until now we are still using this current process, contact process. It's the current method of producing high concentration of sulfuric acid for industrial purposes. Okay, so sulfuric acid again has many uses, especially for industrial purposes. Okay, so jangan tak tahu kita maybe tak pakai, tapi industri pakai. Okay, dia banyak dia digunakan sebagai intermediate, sebagai starting material to produce other chemicals. Okay, alright, so the contact process, like Haber process just now, is very simple, very straightforward. Okay, we only have one reaction. Tapi kalau contact process, dia ada banyak reaction sikit. Okay, it involves several steps. The contact process proceed in 3 steps. Okay, first, kalau nak start from scratch, the production of sulfur dioxide, SO2, okay, where sulfur in solid state react with oxygen gas to produce sulfur dioxide. Okay, alright, as you can see, this is not reversible. That means this one will completely use up. I mean the reactor will be completely used up to produce SO2. Okay, alright, the second step is the one that we are that we can manipulate. Okay, so from SO2 just now, okay, can be used to produce sulfur trioxide, SO2. See, this one will be used in the second step to be reacted with oxygen gas and producing sulfur trioxide. As you can see, this is a reversible reaction. That means at one point it will achieve the equilibrium, and this reaction also is an exothermic reaction. Okay, it releases heat. They produce heat dekat situ. So this is the one that we can manipulate later. Okay, because SO3 is needed to produce the final product, which is the sulfuric acid. Okay, so to produce sulfuric acid, H2SO4 in liquid state will be needed to react with SO3 from second step just now. Okay, to produce this oleum, this liquid called oleum, and this oleum ni sebenarnya dia adalah concentrated form of sulfuric acid. Nama dia oleum. So this is the chemical formula of oleum. Then later this oleum kita tambahkan air, dia akan jadi sulfuric acid in aqueous state. Okay, yang ni yang kita boleh varies dia punya concentration. Some industries may need 98%. Okay, some may need only 20% of sulfuric acid. So kita boleh play around from this. Okay, alright. So these are the steps, but the one that is involved for chemical the one that will be involved in chemical equilibrium is the second step. Okay, alright. So this is the process, guys. Industrially, okay, roughly this is how it looks like. Okay, the first step, sulfur. Okay, react with dry air. So ni ada dia punya temperature lah. As you can see, it will be combined in apa nama tu, in a furnace. Maksudnya dalam keadaan panas lah. You can imagine how high is the temperature. Maksudnya dalam this furnace, dalam chamber lah. Okay, so it will produce SO2. So this SO2 will react with O2, this one, to produce SO3. So SO2, this one dia akan masuk dekat dalam ni, it will produce SO3. Okay, so this SO2 lagi. So dia akan dimasuk dekat dalam ni, this one dia react, dimasukkan dalam this chamber. So in this chamber, we have a catalyst dalam ni. Okay, industri memang kena main dengan catalyst. Okay, alright, so as you can see, the temperature for this reaction is 450 degrees Celsius. Kenapa 450 degrees Celsius? Because again, we have to consider the efficiency of the catalyst. Bukan semestinya you letak catalyst, dia akan react. You kena tahu that catalyst tu, dia punya behavior, okay, dia punya efficiency, dia punya favorite condition. So that it is able to apa nama to work efficiently lah. Okay, dia berfungsi untuk mempercepatkan rate of reaction. So dia ada condition dia yang you kena follow. Kalau dia kena temperature tinggi tapi you bagi temperature rendah, so kita boleh kata that the what do we call that, the catalyst will not act efficiently lah. Dia takkan act efficiently. Okay, sebab you tak follow the condition of the catalyst. Okay, alright. So you have to remember just now Haber dia pakai apa? Iron. For this one, it is vanadium 5 oxide, V2O5. Vanadium 5 oxide. If you miss out the 5, salah. Okay, you can add the vanadium 5 oxide. That's the catalyst. Okay, alright, so in this chamber and then we convert into SO3. See, nampak dia akan keluar daripada sini. And this SO3 later on, okay, dia akan masuk lagi another chamber. Okay, this is takut nak masuk kalau boleh buat lawatan kepada kilang ni. Sebab ni dia very I mean, you tahu sulfuric acid kan, corrosive kan. Okay, so boleh imagine the condition dekat situ lah pada ketika yelah, tapi I believe that dia ada dia punya, safety measures je kan. Dia taklah bersepah asid terpecik-pecik ke, taklah macam tu. Tapi cuma kita worried. Okay. So material yang digunakan tu mesti boleh withstand the acid pH of the acidic pH tu. Kalau tak berkarat lah semua. Okay. Alright. And then later on SO3 just now, okay, will react with H2SO4, this one, concentrated sulfuric acid, dia akan react, okay, and it will produce oleum. So this is oleum, okay, so oleum ni later on, okay, like I said, it is a concentrated sulfuric acid sebenarnya, okay, dia akan add water and will produce sulfuric acid in aqueous state. Okay, right, step number 4. This one step number 4. This one step number 3. Okay, kat sini tulis apa? Adding water to SO3 will directly produce H2SO4. Okay, alright. Sebenarnya SO3 ni, when we add water to SO3, it will directly produce H2SO4 sebenarnya. Kita boleh produce directly. Tapi kenapa nak kena SO3 react with H2SO4 to produce oleum? This is why. This step, however, produce a lot of heat and mist of H2SO4, and this is very corrosive and cause air pollution. This is in terms of safety lah. Okay, even though it is more direct to produce SO3, just react dengan water saja, but it is very dangerous. Okay, they produce a lot of heat. Dia sangat panas, it produce a lot of heat. Nampak tak? Berapa banyak dia release ni? Negative 196 kilojoule tau, per mole. Okay. This is not per mole lah, this is for 2 mole. Okay, sebab this one with respect to this reaction kan, for 2 mole. So imagine you industry takkan produce 2 mole je. Okay, thousands of mole. So you can imagine berapa banyak heat yang diproduce, sangat panas. Okay, I have experience dealing with H2SO4. Saya nak produce dalam Scott bottle tu je. Sikit saja saya nak produce like 90, saya nak produce nak prepare 98% of sulfuric acid. Is it? Don't remember lah. Tapi saya, saya nak produce from 98% of sulfuric acid. You imagine 98%, saya nak dilute into 20% lah. From 98% to 20%. So I have to M1, V1, M2, V2 kan. Saya kena remove from this 98%. Like for example, maybe 20 ml. Okay, saya nak prepare dalam Scott bottle. And then, you kena letak, you ada cara tau. You kena letak air dulu. You tak boleh letak sulfuric acid and then you letak air. So what happen nanti dia dia ada cara dia. Okay, you kena add in the sulfuric acid. You have to add in water, a bit of water into the Scott bottle. Adalah separuh macam tu. Then only you drop slowly, okay, the sulfuric acid. Kalau you letak sulfuric acid and then you letak water dekat situ, dia because the heat produced is very hot, the heat produced tu a lot lah. That's why dia boleh terus jadi mist, okay, dia terus evaporate water tu. So this step is very dangerous. So instead of going for this step, walaupun dia direct tapi it is dangerous, dia kena SO3 tu react dulu dengan concentrated sulfuric acid producing oleum. Then this oleum, okay, baru react dengan water to produce H2SO4 aqueous. Right? Similar to Haber process, the reaction of produced SO3 is reversible, okay, and it is exothermic. By using Le Chatelier's principle, the yield of SO3 can be increased when temperature is decreased and pressure is increased. Okay, ingat, we want this one, SO3, because SO3 will be used to produce H2SO4. So how can we manipulate the reaction so that we produce more SO3? So sama macam Haber just now. It's either we decrease the temperature or we increase the pressure. But the problem about these two methods is when it is very high pressure, it's not economical and it is very high cost. And low temperature, on the other hand, cause the rate of reaction to decrease. Increase the product, but the rate of reaction will be slower. Okay, therefore, a compromised temperature and pressure, which is the optimum condition of around 400 to 500 degrees Celsius and 2 ATM. This one, the ATM dia is not as high compared to Haber just now, 200. This one 2 ATM. But consider lebih, kita punya current is 1 ATM, dia 2 ATM. Okay, so the catalyst used is vanadium 5 oxide. Right? Okay, so please remember please memorize the catalyst used for both reaction. Okay, all right. Okay, maybe you can try this checkpoint 22. Okay, very quickly based on what you have learned just now. Okay, cuba jawab dulu. Ada berapa soalan ni? A, B, C. Yeah, A, B and C. I give you 2 minutes. Okay, tak ada calculation pun. Just jawab sahaja. Okay, alright. Ammonia and sulfuric acid can be manufactured industrially using Haber process and contact process respectively. A. Name the catalyst used in Haber and contact process and explain the benefit of using catalyst in Haber and contact process. Alright, so let's go for Haber first. So what is the catalyst used in Haber process, guys?
Again.
Iron. Okay, alright, so the catalyst used in Haber process is iron. Dia tak dicakap kan iron apa Dia ada cakap ke? Iron satu je iron. Okay, so iron tu dia boleh produce iron 3 and iron 2 kan? Kita ni depends on the reaction, betul tak? Okay. Dia tak ada cakap. Dia kena specify tapi tak cakap. Tak apalah. Sorry, mana ni air ni? Tak ada. Iron je. Okay, tak apa. Iron. Okay, alright. So how about what's the catalyst used in contact process, guys?
Vanadium dioxide.
Vanadium 5 oxide. Okay, this one should be near close to the last alphabet from the first word. Okay, for the first dia patut jangan ada gap this is the format of writing ionic compound. Okay, and then explain the benefit of using catalyst in Haber and contact process. What is the benefit of using catalyst, guys?
Lower activation energy.
Okay, alright. So catalyst, catalyst has the ability to lower the activation energy, but you need to relate with the rate. Okay, so don't end your answer just by saying lower the activation energy. If you want, that means so far dalam this application the catalyst help to increase the rate of reaction by lowering the EA. Tapi untuk kita punya explanation for the one that we want, the one that we are more interested in is in terms of rate. Kita nak rate. Okay, so you kena cakap rate because it increase the rate of reaction. Okay, so kalau you nak tambah by lowering the activation energy. Sebab this is application already. This is already application. Just now kita belajar the fundamental. So the fundamental is the basic. Okay, and then you have the application. So application ni is more on the surface sebenarnya. Tapi kita tahu dalam hati kita, kenapa the rate of reaction increases? Because it has the ability to lower the EA. Okay, tapi sebenarnya yang soalan nak you subject to this one because it's catalyst has the ability to increase the rate of reaction. That is the one. Okay, so kalau you cakap tadi lowering the EA, okay, bagus, tapi you have to have the rate of reaction. That is important. Kalau tak kita akan kita akan cakap macam tu. So, okay. So you have to always relate with the rate of reaction. Kena ada conclusion dia dekat situ. The benefit of using catalyst in Haber because this is industrial already. Bila industrial tu kita not so we are not so concerned on dia punya fundamental dia tu. Okay, orang industri dengan saintis dia selalu konflik sebab industri dia pentingkan duit, ekonomik punya perspektif. Tapi kita saintis, kita nak tahu dia why, how, what happen kan. Kita nak tahu, and we tend to spend a lot of money lah on nak buat this experiment. Tapi industri tak suka macam tu. Dia nak yang profitable. Okay, alright. So just now the answer should be because the catalyst has the ability to increase the rate of reaction. Okay, you can tambah by lowering the EA. Okay, why lower temperature is not used in the production of sulfur trioxide in contact process? Okay, guys, kenapa dia tidak digunakan? Why lowering the temperature is not used? Kenapa lower temperature is not used? Why? Why?
Decrease rate of reaction.
Okay, because lower temperature will decrease the rate of reaction. Okay, so bila decrease rate of reaction, it will take longer time to produce product. Yes, it will produce more product, but it will take longer time. We don't have time. The industry don't have time. Okay, we want it to be now, as fast as we can lah kan, in order to produce the product. Okay, we don't want to wait. Kenapa nak tunggu? Bila you tunggu, that means you profit lambat lah, ataupun you rugi sebenarnya. Okay. Write the reaction equation in which catalyst vanadium V oxide is used in contact process. See, you have to know which part yang dia menggunakan vanadium V oxide. Yang step number 2 tu lah. Okay, yang SO2 produce react with O2 if I'm not mistaken. Okay, betul tak? SO3. Make sure dia balance apa dia punya balance tadi? Malas nak ni Jangan jadi macam saya, 2. Okay, you kena balance sendiri lah. 2. This is gas, this is also gas. Okay, alright, so this is the reaction where catalyst is used in the contact process. Catalyst cause the active. Oh, ada lah kat sini. Ya. Okay, betul lah macam saya cakap tadi, tapi you kena make sure that you relate dengan rate. Okay, dah good enough you beritahu tu, tapi relate dengan rate. However, catalyst does not affect the yield of product. Dia takkan affect. Catalyst does not affect the yield of product. It increase the rate of reaction. At the same time, it will produce more product. Bukan more product. It will produce product at shorter time. Macam tu. Okay. So dia punya produk tu kalau 1 hour dia produce like 5 kilo of product. Okay. Tanpa catalyst. Tapi catalyst ni dia mempercepatkan reaction kan. That one is 1 hour 5 kilo. Tapi kalau you are using catalyst, when we use catalyst, it can produce like 10 minutes punya 10 minute punya time, you can produce like 5 kilo of product. Okay, imagine kalau you ada 1 hour. Kenapa? However, catalyst does not affect the yield of product. The yield of product, I mean in terms of product tu yang dia produce kot. Think so lah. Does not affect the yield of product. What do you mean by the yield of product? Okay. Okay, B. Why lower temperature is not used? Tadi lower temperature causes the rate of reaction to be slower, therefore longer reaction time, not economic. Okay, this one, this is the reaction. Okay, done. End of topic 2, guys.